Thank you. So I tried to put all the buzzwords I could in my title to make as many of you as possible to come. The project, I'll sort of start by saying a bit about the background, which I think is a bit unusual. And this is actually a project that I got funding for from something called the Google Digital News Initiative. And I'm working on it at the Alan Turing Institute, which I think is a perfect fit for this kind of project. And what the Digital News Initiative does is that they sort of support projects, innovative projects that combine computing or data science or anything sort of related to modern technology with news and journalism. So they've sort of funded quite a large number of interesting projects at the intersection of journalism and computing. And my background is more on the sort of computing side. I did some work on programming languages, and one of the interesting things I've worked on in the past was integrating data into programming languages. And that sort of led me to an interest in how could you easily integrate data into not just programs, but also things like articles on the internet or journal or whatever sort of articles journalists write in the media. How could we make it easier for them to use data, and how could we make it sort of more transparent and open? And I wrote this proposal roughly a year ago, and I sort of didn't really expect how timely that will be. If you've been following the news recently, there's a lot of talking about post-fact world, where I'm not going to name anyone, but the idea is that it's sort of becoming harder and harder to talk about facts on the internet, or in general in sort of discussions where facts have been sort of replaced by opinions, and everyone can have their own opinion, and it only depends on how loudly they express it. There's been a lot of criticism for social networks and things like Facebook, which sort of support this echo chamber and so on and so on. But I think there's sort of a slightly different view you can take on this, which is that social networks and Facebook actually did quite an amazing job at democratizing opinions. So everyone can share their opinions and discuss them and so on. And I think the bit that's missing is that we don't have anything like this for facts. So if you want to find some facts in, say, open government data, it's a lot of work. And I think many people here who are data scientists know the different parts of how hard it is. You have to sort of find the right data set, then you can't parse it because it has wrong format. Then you can't really find the right number. Then it turns out that to get the number, you need to link together multiple data sets, which is a hard research question because the column names are different. And then you want to write some nice chart, which turns out to need the D3.js, which is an amazing library, but it's really hard to use. So I think there is a lot that we can do in sort of making facts easier to use, easier to fork and create derivations and so on. And that's sort of the idea behind the work. And on the journalism side, it fits really nicely into something that's called data-driven storytelling or data journalism, where I'll start with one really nice example. So this is a article that the New York Times did around the Olympic Games, which sort of looks at the different medals across the entire history of Olympic Games. So you can see, like, it shows some really interesting facts that you wouldn't sort of normally realize if you didn't see the picture, because there's two holes, which is that during the World Wars there were no Olympic Games, then there's this spike here in Soviet Union and United States dominating because the other one didn't go to the Olympics in protest. So it really nicely sort of shows some of the facts. And I think this is a great way to make sort of facts more fun and more sexy. The one difficult thing with this is that if you want to do this, you have to do it in a reproducible and sort of transparent and correct way. So if you look at article or report like this, the first question you can ask is, can I actually reproduce it? Can I rerun it? And there's this interesting story about a report called Growth in a Time of Debt by Reinhardt and Rogoff, which sort of influenced how governments decided to react to the financial crisis, which was sort of saying if you have large debt, then growth in the country will be smaller. And it turned out that the article couldn't really be reproduced because I think the data analytics was done in Excel, and they sort of did off by one column or off by one row error. I'm simplifying things, but you can't sort of reproduce it because it involves a lot of manual work. You really have to get the data, copy it somewhere, do this step, this step. It's not like running a program that would do it for you. The other thing where I think we need to make this more open is there's lots of different ways to present the data that can sort of support different stories. So you can easily create misleading visualizations. And here, for example, even with the Olympics, you can take rowing as 8 medals or 1 medal, and it really skews the picture. So what I've been working on is sort of making it easier to create reproducible and open articles that use data and tell some stories. And I'll show one quick example. I'll have a bunch of different examples, and this is a first one. I'll give you links at the end as well, where this is looking at some data about the Olympic Games, and it's sort of trying to reproduce some of the reports that people wrote, created during the Olympic Games. So here is a total sort of league or medal table where you see the individual athletes and how many medals they've got. There's a sort of timeline that plots different sort of, as the time goes, you can see where the different blobs of medals were. So at the beginning, there's mostly a European business, but then it sort of spreads across the world. And the interesting thing, and I'll say more about this, is that for every single of these, you can actually see the source code, which sort of represents, I'll move it up a bit, which represents the data transformations that I had to do to get the data from some original primary data source, which is just a list with every single medal ever awarded. So this part here represents the data transformation. In this example, there's a little bit of ugly work in progress part that I need to make easier, but you could imagine reading this, and I think some of the people here would get quite a good idea what this means. So this was just the motivation, and I think that the key idea is that you can really see a data-driven article or report like this as a program, which gets some data, builds some visualizations, and I think this is really a powerful paradigm for thinking about it, because not just you can sort of download the data from somewhere, but you could make articles that are more dynamic, and when a new budget report is announced next year, you could sort of just rerun it and let it generate the new version of the article, which tells slightly different things. So we're quite far from sort of doing all the magic that we could, but this is a very powerful way of thinking about it that sort of lets us bring lots of the nice programming ideas into making reporting more open. And when you look at what I was showing before, really we start just by seeing some resulting story. So it's not different than what you see today when you read the news, but then because it's an article, we can let the readers modify some parameters and explore different things, or we can let the sort of power users or those who know a bit about programming or those who are just interested actually explore how it's been created. So I think the sort of most interesting part of what I was working on is once we see articles as programs, what are the different things that we can do? And my background is programming language research. So in programming languages, there's lots of clever tricks that people come up with for doing stuff with programs. And when you're writing code, you can see it in your editor, where it tells you, oh, maybe you mean this. Or the compiler will tell you, well, I think this is probably wrong because of this. So can we bring some of these nice ideas into the reporting or working with data? So the first example I've got is letting the readers modify some parameters. And for that, I'm going to use this one, and I'll have to change. So this is the bit where it's currently a bit ugly. I'll have to change one number, because otherwise it looks bad. But once the number is changed, I just made the bubbles really huge. This should be done in a more clever way. But the nice thing is, aside from the source, I also have this options button here. And the way this works is that it takes a look at the source code, it does some source code analysis, and it figures out where in the code are places where I'm possibly sort of selecting or defining a list of things. And I can give you sort of a description of what this is precisely in terms of types, but that's not really the key thing here. So here it sort of identifies there's a drop down or there's a list of things where I can select the disciplines, how I group them, and how I sort them. When I select the disciplines, I can pick, so let's do wrestling. And then when I change it here, you can see the map sort of plotting how different countries were winning wrestling. And there was the Russia blocking the not coming to the Olympics blob in like 80s or something. So they get really big, and then poof. And as I'm changing the code here, so as I'm changing the selection here, so let's look at cycling instead. And you can sort of create the list, but as I'm changing the list, it's not only changing what you see in the map, but it also changes the code. So that's maybe an interesting aspect, which sort of is an incentive to learn about how the code works when you see how it changes based on how you interact. But the idea is once we have the code, we can analyze it and expose all these user interface options and do other interesting things, letting the readers change some parameters and so on. So this was the first one. Another, I think, an interesting area where a lot of research has been done in programming languages that can be transferred or used in data science or reporting is simplifying access to data. And this is a huge topic, and I'm not even going to pretend I sort of know how to solve it, but I'll show you one aspect of it which I think is interesting. So one thing you might want to do here is to say, well, what are some things I can say about the world using data sets like the Open Government data set in the UK, or the demo I have is using the World Bank. So World Bank has data set on countries and all sorts of different indicators about countries. And this is showing total carbon emissions in kilotons. So you can see China, I think this is in 2010, maybe. This is a nice problem. So now I forgot what year this is using, and I can look at the code and tell you. And it is indeed 2010. Now, can you sort of see it? I'll maybe sit down a bit. So here, the interesting thing is that in the programming environment, and this is slightly old prototype, so it takes a bit of time, we can use all the sort of programming help tooling that people who write professionally software are used to, like auto-completion, which in the context of software gives you like all the operations I can do on this object, or all the functions that are available in this library. But here, it gives me all the data that's available in the data source. So world, this bit, is some sort of representation of my data source, and that's where I had to do some clever work to integrate the World Bank data set into my environment. But then I can say, give me data for one specific year, and I can pick the year I'm interested in. And then it goes back to the data source and says, what are all the different groups of data sets that you have for this year? So the World Bank collects various sort of growth and development indicators, like, there's a massive list of things: poverty, gender equality, education. And here I was looking at climate change. So let's stick to that. And inside climate change, you can access all these different series that the data source has. And the other nice thing is here on the side, because I know sort of where the data is coming from, I can trace it all the way back to the original source. I can actually tell you all the other metadata that the World Bank knows. So maybe let's change the map to show metric tons per capita, because that's possibly an interesting indicator. When I sort of do it here, I can see where they got it from. And you could sort of add a lot more there. So here, I changed it in my code, and I can refresh it, and then it takes a little bit of time again, because it's not the fanciest new version of the project. But I think eventually we'll get a different chart. Maybe. We'll see. If no, I can show you one other thing, which is that I was changing the list in the code. And again, that's something I can turn into a user interface. And just like I had carbon emissions in the original list, I now have it in a fairly normal user interface. So I can choose per capita here, and it's using the same data. It's operating on the same structures. So then I click refresh, and if everything goes well, we get a new map that shows different data. So this was wrong button. This is another thing you can do once you treat your data transformations as program. And the last thing I want to show is how can we sort of improve the programming user experience. And this is something I've been thinking about quite a lot, because there is a massive gap between what people can do in Excel and what people can do in programming languages. There's millions or billions of people on the planet who can use Excel to do interesting data analysis or do useful things, but there's sort of significantly lower number of programmers who can do even the similar thing, really. And so what is it about Excel that makes it so usable, and what can we sort of learn from it in our programming languages context? And this is the most recent incarnation of what I've been working on. So here, this is again just a chart with the medalist, I think, sorted by gold. But maybe you're wondering who's the most unlucky person in the Olympics who only wins bronze medals. So who has the largest number of bronze medals? And I can, again, here look at the code. And this looks like what I was showing before. So the really interesting idea here from sort of one programming language perspective is that all of this, all of this gets the sort of same support as when you're editing, but instead of saying call this method which takes this parameter and so on, it is really sort of very limited language. So all you write is dot, and then it tells you what you can do there. So that's one part. The other part is that as I'm looking at it, it will actually, as I'm sort of moving through the code, it will tell me what is it that my data looks like. So the idea from Excel is not just sort of making it simple, but I think more importantly, what makes Excel so powerful is that you always see your data. You never program with abstract variables like x17. You sort of refer to concrete cells in Excel spreadsheets and you know what the number there is. So here, I sort of still have the code there, but at the same time I can see what is the current state of my data. So if I say group by athlete, I see all the athletes. If I then scroll here and say sum gold, it will sum all the gold medals for the athletes. If I sort of typed dot here and said sum bronze, then immediately I will see what the total number of bronze medals is. And the other sort of idea here is that I can do all this by editing the code, but equally I can do it through the user interface. So I can actually sort of click at the different stages of the transformation and maybe in the sorting say remove by gold descending, and you will see that it modifies the code and the sorting is gone, and rather than having that, I can pick from the other available columns at this point and say sorted by bronze. And here at the end, when I say get series, that means give me the actual data with key athlete. So for every athlete, we want to get number of bronze medals. And again, I see this sort of happening live, and you can even see the charts live. So here's our top 4 athletes who have 6 bronze medals, and I think one of them hasn't won any single other medal. So they just have 6 bronze medals. So that was the sort of last bit of programming language research that you can try to take into this data science or data-driven storytelling world. So the sort of key point is, I think, article as a program is a really powerful paradigm. And the project, I mentioned that it's funded from the Google Digital News Initiative, and one of the sort of ideas there is to also build something that will be usable, not just do sort of research. And so all of the code that I was showing is available on GitHub, and I'm working on having a nice package which will let anyone take it, embed it in their websites, provide their own data sources, or sort of clone any of the samples, and so on. And I think there's also lots of interesting places for collaboration here. And I've been talking with some journalists, which is sort of the obvious source. But there's also, we've been talking with James about how can we expose all the UK government data in this easily accessible way. And I think there's an enormous potential for automagic linking and cleaning of data, because the data I would like to sort of expose in this way usually is very messy, and using some clever machine learning techniques to make that recover that structure could be a good thing. So the summary is, make facts great again. And I think the way to do it is by using all the great open data that we have, by using all the great data science techniques, and by sort of linking it together through some programming languages research. Thank you. And now that I'm done with demos, you can play here.